All right. Are we ready to save Jim?
I am ready. I am ready. Yes, more than anybody. So
Awesome. Well, hey guys, good to have you here. To everyone
Let's
in
see
the
if we
audience.
got.
Hey,
so
missed
Well-
that.
Oh yeah.
he said Happy Victoria Day.
Oh yeah, up here in Canada, we had a day off yesterday. We're back up and running here, ready to save Jim. So everyone in the audience, my name's Ben. I'm from ZOA, and we make the HAVEN IAQ platform. Who wants to go next?
I'll go ahead. This is Jim. I'm the guy that's getting the migraines in the office here. We've interesting project for us because we're real big on obviously making measurements, but also being able to do something about it. And that's really what this project's about. And that's why we brought in Nate and Michael and obviously Ben. We're all working on this sort of together. It should be a good project. So, Nate.
So I'm Nate Adams of HVAC 2.0, sometimes known as Nate the House Whisperer. So Badass HVAC was kind of a joke that came out of my head and those of a bunch of others, like a house here named The Bad for Big Air Drop. So Jim, you're going to get one, and we'll see if it can save you from some migraines.
Yeah.
And I am Michael Hausch, kind of a 2.0 member, founding member, and kind of known for some of my 3D duct designs. And so part of my role is to design the badass system for this project.
I remember when I was at AHR in 2019, I think it was yourself, Nate, that introduced me to Michael when you came by our booth. And I think, Michael, you were introduced as the unicorn tech to me. And so it's always stuck out in my head that you are the unicorn tech, whatever that means. But no, I've really loved kind of watching all the work that you do with HVAC 2.0, and also what you've done with our product. You've done lots of interesting experiments. So hopefully we can use your expertise to do some experiments here with Jim, and hopefully not kill him in the process of doing those experiments.
Yeah. So I think it's important we preface this a little bit because one of the things that we're in the same office as the TrueTech Tools, so we have there's a lot of people at TrueTech, and different people do different things. So we got people that cook in our kitchen and air fryer, and we've got somebody that likes candles and candles going all the time. And for whatever reason, my area gets all those smells sort of deposited. I must be in like a low pressure zone in a building or something, but it ends up that we get a lot of poor indoor air quality. And honestly, it has affected my health. I actually feel better at home now that I put in some extra filtering than I do at work. And that's sort of what led to this project. But the bigger thing was when we were starting to work on the HVAC 2.0 project and really looking at modifying these systems, was the ZOA or the HAVEN instrument makes a lot of really interesting measurements, but it was like, okay, this is cool, but how do we now we see have a problem, how do we fix it? And our thought was with this project was to test different IAQ solutions and see how they impact the indoor air environment at the office here. So different types of filtering, UV lighting, different types of humidity control, so humidifiers, dehumidifiers, introduction of outdoor air. But really, when we're looking at setting this up, was trying to set up a lab in here and actually use our office as the lab, so that we not only have the measurements and the solutions, but also have some personal experience with just the overall indoor quality and the health. Right now it's just like we know we have like a ton of box dust. We have a lot of tree pollen. We have a lot of semi trucks pulling in and out for TrueTech deliveries, and so honestly, my background's really system commissioning. So we brought Michael in because he's really good with a duct design and air conditioning design and just sort of the layout of the project, so we could figure out some solutions for that. Nate's just got a passion for science and understanding how to improve quality of life for occupants. And Ben just happened to have the right tool at the right time that we could drag him along. So it should be a very interesting experiment. What's that, Nate? You pixelated again.
Ah, nuts. All right. I'm probably going to move here so that I get a better signal. I was just saying the only reason we had Ben on was for his equipment. That's it.
And the hair. Gotta add some color to the conversation and to the testing.
So we also just got I think we're going to have General Air Filters got a very extensive product line. They've one of their reps has displayed some interest in working with us.
Awesome.
So they have everything from humidifiers to dehumidifiers to all kinds of different filtering equipment, some different types of UV lights and things that we can try out in the project. Then we are going to bring in outdoor air for ventilation. And we're playing around with some different duct designs, and we're going to be using, equipment-wise, we got a Bosch heat pump, a Bosch the Bosch 2.0 variable speed heat pump, which we want to really look at that, as far as like temperature and humidity control in the space, because it is a full modulating piece of equipment, and what we can do with that. So we have the Bosch air handler, we have a electric reheat for this thing. So, the whole idea behind this too is, as we're doing some experimentation, we like some feedback from people that are watching this project on things they'd like us to try, to maybe either introduce some problems to the system or fix some things just in general, so we can look at it. And I think the other thing we're going to do is we're going to put on a watt meter on this thing, also in a separate panel, electrical panel, so we can actually measure the electrical usage of some of the solutions that we're implementing, like electric reheat or things like that, to show cost benefit to the to the system. So that we're trying to think of a lot of different angles we can do this, so we can.
Sorry about that.
It's all right. So don't let it happen again. So that we can really try and understand a little bit better indoor air quality with some of the tools that we have at our disposal today. I think a lot of techs, and me included, I mean, I've bought things, people have told me, hey, this will do that, or this will do that, and put it on your system. And it's like, with ZOA and HAVEN, it's the first time we don't have what I would call as a butt dyno. Like you used to say with your car, you change your air filter out or change your spark plugs, and your butt dyno would tell you it's better. And I think it's the same thing with HVAC. We think a lot of times we put a UV light in, our air quality improved, and it's like, well, did it really improve or not? Because we just haven't had a tool to this point to actually measure that improvement. And that's what we're going to be doing with the HAVEN, is baselining the system, understanding what the particulates are, the CO2 is, the humidity is, the temperature is, and then monitor that, and then implement some different filtering and different humidity control solutions and different temperature control solutions, and just see how it impacts the overall quality of the indoor air. And it can even be simple stuff like, once a week, and we have these Swiffers. We have like a tabletop in here that we can keep cleaned off, and just wiping it down once a week, just to look at particulates on our furniture and stuff, how much dirt we pick up. So it doesn't have to be like, we don't have, this isn't pure science, but it is going to use a lot of scientific method. So I think there'll be some good stuff come out of this. But at least if you guys have suggestions as we go, we'd like to try and implement them.
Yeah, applied science is
applied.
I like to use. Yeah.
Yep.
Yeah.
But yeah, that's
real world stuff.
That. Yeah, and this is a residential HVAC system too. That's something to kind of clarify here. That even though that we're putting it into Jim's office, we're designing it as if it is an HVAC system that's serving a living space that somebody would be using as their primary dwelling. So I think Jim, you probably spend like at least 5 days a week in there, or are you there evenings and
I'm
weekends too?
6 days a week, and sometimes 12 to 14 hours a day at the office. So it's
Pretty much live there.
yeah, I pretty much live there. And the other thing too, I think that's important. We were going to initially build a training unit just for showing how ZOA worked. And one of the things we figured out really quickly was we needed a control environment to really. Otherwise, we're sensing particles or we're sensing humidity or sensing temperature, but there's really nothing we can do with it, right? So having a control environment in my office here was one of the key elements of this design, so we could start to understand a little bit better about the impacts of what we're trying to do. So it's going to be interesting. I'm sure we'll get a lot of feedback on this as we do things, but at the end of the day, what I'm hoping we accomplish here is cost-effective solutions that contractors can use a product like HAVEN to identify the problem, implement a solution, and have a lot of confidence that it's going to be resolved. And so instead of you spending money to figure this out, we're going to have, we're using some industry contacts, or using some of our own money, some of our own time and talent, just to sort of prove this thing out. And so that, at the end of the study, we should know what things we can implement that are cost effective, good strategies that work for you, work for the customer. And really important, that when you're using an indoor air quality meter, that you can measure it, you can identify the problem, and then either mitigate the source, or filter it out, or dilute it, or whatever we end up, whatever the control solution ends up being for this. But you have confidence at the end of the day that if you implement that solution, your customer will get the results they're looking for. Because there's nothing worse than telling somebody you're going to put something in, you're going to control the humidity better, or you're going to I've talked to contractors that said, yeah, I put this system in because it was going to control the humidity better, and now it's worse. And and they're frustrated, their customers frustrated. Sometimes it's control strategies that we got to change, and sometimes it can be as simple as I ordered a filter the other day for one of my units here, and air was bypassing. It had a 1/4-inch gap around the filter, right? It's going to be as simple as installation issues that maybe we're overlooking and things like that. So I think there's a lot of things we can learn along the way here.
Got a couple questions from the chat on YouTube. One is an important one for Michael. I think Jenry Garcia is asking if you have a Diet Coke there. Is that?
Oh, only 4 roses for me, Jenry. You know that.
And for yourself, Jim, Dave asked if you suffer from allergies, or what specifically do you know what your reaction to air quality?
Yeah, so I know I never had allergies when I was a kid, but as I got older, my tolerance to particularly pollens and dust has gone way down. And so and then the other thing that really gets me is candles. Like somebody burning. We have guys here that burn wax burners, because I don't know what the heck's wrong with millennials. So, but they're burning their wax, in the office, and the smell of it. The other day, it was like a watermelon bubble gum, and I was walking around here trying to figure out what it was. And I don't know if anybody's ever had a migraine, you get a significantly increased sensitivity of smell and light, are two things. And so if you want to take something, most people say, oh, I smell it in the background, amplify it times 10 or 15 or 100 times. It's like all of a sudden you got the nose power of a dog, and it's just overwhelming. And then, the only way to get rid of these types of smells, obviously, is to ventilate the space, but I have no way of controlling that right now in my house. So, and so I found that, like my throat constricts a little bit when I'll walk outside in the morning, and I have really, really heavy tree pollen, and I can feel my throat constrict up just from the being outside and the tree pollen out there. So in my house, I put in 2 MERV 11 filters that are 16 by 25, and I have right now I'm running between 500 CFM and 1,000 CFM through my unit. So my filter face velocity is really, really low, which is really helping with particulates in the house. And notice the dramatic improvement there. But in my house, I don't have makeup air. I don't have a humidifier. I don't have a dedicated dehumidifier. I'm relying on the air conditioner for that. So I'm looking at, actually testing some of these solutions in here before I implement them at my house. Because I don't want to be a guinea pig two places. One's bad enough. So, but that's the whole idea behind this, is just, because honestly, it is affecting my health. And then when when you spend 14 hours a day here and you're miserable, and it's not every day, it's just some days, so, but when we're just in an environment where there's a lot of packaging going on, a lot of trucks coming in, a lot of trees, a lot of pine trees outside. So we get a lot of just a lot of pollens, in the air in general. And for whatever reason, this office is, I think there's a pretty serious stack effect on the building, as big as it is, that just whips air through our office. So, I was reading just the other day that to drop the humidity from like 60% to 50% takes approximately 10 hours of runtime on an air conditioner to drop the humidity 10 points. But to regain the humidity took 5 to 7 minutes, right? And I think that's literally the way it is in my office too, is we'll get it to where the air quality is decent, and then all of a sudden something will change dramatically and the air quality just drops. And it could be open up garage doors, it could be wind, it could be whatever, but I'm hoping we can control that, measure it. And I think the cool thing too with HAVEN is eventually the controls that will interact with it to allow it to turn on ventilation, to turn on humidifier, to turn off, to control things so we can actually measure and respond, to what elements we can control in the system.
Yeah, we're really excited about that. We're coming out with our new central air controller later this year for 24-volt systems, and then we want to do some software integrations, cloud to cloud, between systems like Carrier, Infinity, or Nest, or I think Train Nexia.
Yep.
Pretty much any of those systems over time, we want to have that type of connection so that if there is an air quality event, you are able to have it taken care of for you automatically based on the HVAC equipment that is installed in the home that was designed properly as a part of kind of the holistic strategy to manage your ventilation, filtration, and humidity problems inside of the home. So, Jim, can you take us for a tour of your office?
Yeah, let me
a mobile tour.
I'm going to switch devices here. So I'm going to plug in, I'm going to go off and then come back on again. So give me just 1 second. And
Yeah, sounds good.
join the meeting. There's a couple questions too. It looks like Terry. I don't know if it's, I don't even know how to pronounce that name. Tertiary?
Tertiary.
Tertiary.
Yeah, tertiary adjunct.
All right. Well, that's a new one for me. Yeah, we actually are on chat. We're just chatting and ignoring everything that's going on beside us. So I apologize in advance. But Aprilaire is a brand that I've used quite a bit. They make some great products too. But the carpeting in here, we do vacuum it quite a bit. And I got a Boston Terrier who does not like cold feet, so he doesn't wear shoes. So I have to carpet it for him. It's one of those things. But we can't remove it because it's direct glue down. So it's there's no way to redo the flooring in here. We do vacuum all the time, and it's amazing how much dirt. I've always been amazed, even in my own house. We keep a pretty clean house. How much dirt comes out of carpeting. So I agree with you 100% that it's one of those things that if you can get rid of it, it definitely can increase the air quality of a house. So let me switch devices here. Give me 1 second. I'm going to join here, and I'm going to leave here.
Can't hear you yet, Jim.
Would you talk to the accuracy of your PM sensor?
Yeah. So we have so our device. Let me just pull one out here from the ductwork. I got let's see if I can focus in on myself. Perfect. There we are. So this is a central air monitor. It's kind of seen a little bit of better wear. I've done a lot of experiments with it, but it goes into the ductwork kind of like this through the faceplate, and it connects to your Wi-Fi. You can get power directly from the R and the C terminals, and the kind of the sensing happens through these apertures right here. And we have a PM, VOC, temperature, humidity, and even a flow sensor inside of those holes. And we have been able to achieve an R squared sort of repeatability with the I think not a dust track, but there's a piece of lab equipment that we tested against, and we got a 0.99 kind of correlation. Which is really, really difficult to be able to achieve for a consumer grade air quality monitor. So we're really more in the prosumer kind of side of things instead of just consumer grade.
Sorry, guys.
Yeah,
I didn't mean to overtalk you there.
And Jim, for some reason let's see if we can get your iPad up here. Right now it's just showing up as being black in the live stream. Oh, no, you are there. So, but I just can't hear you.
All right, hold on.
I hear you.
Oh, you hear
me?
Yeah, I hear him.
Yeah, I
I
hear
hear
him
him
too.
and see him.
Yeah.
Cool.
I mean,
Well, I don't.
talking
So
to
you guys just
myself.
let me know what he says.
All right. So let me flip around here to the front camera. We'll see if it's going to work here.
Why won't it let me? I'm having a technical.
Yeah, do the fourplex. Yeah, the fourplex we can. Whoop, or now he's gone.
No, I'm just changing some settings. I just can't put him into the highlighted version. So we'll just let him go. Hopefully he
Well, I can't see or hear him now. Howsh, can you see
I
him?
don't see him now that he tried to go front-facing camera.
All right. Well, it may not work.
Well, we might have to tell Jim to kind of leave and rejoin here.
I did that already. I left and
In the meantime,
Just go, Jim. Just go. So, Ben, I want to zoom back in on that 0.99, though. What you're saying is it's possible, or the numbers look like the Haven may actually be a reference grade instrument.
it's getting close. It's not quite a full reference. Oh, there, Jim's back.
Yeah, for whatever reason, we tried it, Ben, beforehand. It worked, and now it decided it does not work. So, c'est la vie.
Well, you can try it one more time. So if you exit the...
yeah, let me try it one more time, and I'd be glad to do that.
So much for saving Jim.
We lost Jim. The project didn't even start, and we already lost Jim.
Jim's dead. Game over.
But yeah, we're really excited about the repeatability that we've been able to achieve in our platform, or with our product, with our hardware. That's been one of the things that we've spent a huge amount of effort in doing lab tests. And so, if somebody's interested, they can contact us and ask us for that white paper.
All right, look, hey, I think I got
working
myself.
now, Jim.
All right. So what I've got here is we got a lab that I built for pretty much just testing our equipment things out here, and we've got different equipment, and basically on this wall here is where we're going to put that unit. So when you saw those drawings Michael did, saw the mini split there. We're going to go up through this wall, so we got quite a bit of space there above a drop ceiling to work with, and then sort of poke through the office, on this interior wall here. And so, you can see pretty much TruTech Tools, this giant warehouse facility. So we'll just, like here, I'm running an air conditioning system. We're just rejecting the heat in the space. So it's about 80 degrees out here right now. But for what we're doing, it'll work. It'll work just fine. But it gives you an idea of what we're trying to do here is just to build a system that's going to be more permanent, and then we'll use the office space as a test, as a test room. So when we have this set up, we can close the door here. We can close the door over here. There's some things going on, like if you look at, like at the ceiling here, the way they did the walls in here, this is probably why I get smells coming across the rooms, just because I have a ceiling gap here. So it'll be interesting to see if we can like reverse the pressure and stuff in that, and make it all work. So it's just, you know, just pretty much just a basic office space for measureQuick, and it's just three or four of us here at a time. There's Mr. Waffles sleeping on a chair. So we get the dog, Waffles. There you go. Wake up. So, but and who would want to get rid of that carpet? I mean, come on now, say get rid of the carpet.
Oh, that's brilliant.
I mean, you can't get rid of carpet like this. So, you know, this is the kind of thing.
Likes it too much.
That's the kind of things we're working with. All right, so I'm gonna go back to the front camera and see if that works. All right, so that was the 2-cent tour.
Cool. Thanks, Jim. I think we have a couple questions. Somebody's asking about how many square feet per ton do you have?
So we're pretty small office space in here. It's I want to say it's under 1,000 square feet, and the Bosch will go down to 1.5 tons. We got some people load in here, computer load in here, lighting load in here for fluorescent lighting, and then just over top there's no insulation over my ceiling, so it gets, you know, pretty warm above the ceiling just from the like shop temperature, but not a lot of load. I would say, you know, right now I've got a mini split in here, but I've also got the office system. And what happens is the office system will satisfy the office before it satisfies my office. So once in a while we supplement with the mini split just to, you know, just to attempt to get the humidity out or drop the temperature down or warm it up a few degrees in here. But this would be a good test for the Bosch too, because we're going to turn it way down as far as we can in most of the time. But we'll probably size the ductwork, you know, for probably 2 tons of air overall in the space, and then probably turn it down. We'll see how far down we can run that unit. But I know we can run it down. I'm running mine in my house. I've got a Bosch unit, 3-ton. I'm running down to 500 CFM range, and it's working pretty well right now. So.
And so the Bosch unit is a heat pump, and I think there's like, what's special about this Bosch unit? Why a heat pump for this build? Nate, why is that important? If Nate is not frozen. Oh, there he is.
Can you hear me? All right. No, I had myself on mute, so you don't hear too many birds. But part of this is a load thing. I mean, putting a furnace in Jim's office is stupid, because even putting a 3-ton heat pump in is probably borderline stupid. But you know, the smallest we can do is 2 in unitary. This is a 2 or a 3. So, you know, it just kind of is what it is. Yep, sorry. But also, this is the direction that we're going to be seeing a lot of the industry heading in anyway. So the lower output allows for better comfort, and then it also allows it to run on renewable electricity as well. So it's been kind of fun. Jim, what's been your experience with the Bosch at your house?
So far, I'm on the camp of electrify everything or nothing, because just the cost of the gas meter. The heating wise, it was really quite comfortable, but it cost $50 more, and I'm cheap, so I went back to the gas.
It was $30 more, tough guy. You told me it was 50 for electricity instead of 20.
Well, you know, it still made my whatever. It was expensive. But if I didn't have the gas meter, it would make a lot more sense. Now, what it does do, though, really good is, honestly, what it does really good is on the shoulder seasons, the comfort is substantially higher, because even in mild weather, like 45, 50 degrees, I was getting really long run times, like 8 to 9 hour run times on the heating side. So it was getting the temperature sort of balanced out, and you know, making the house a lot more comfortable. Now, the other thing that's interesting is on the cooling side, on like 80 to 85 degree days. So far, I think the longest runtime was almost 19 hours continuous runtime. And the electric bill for the cooling's been extremely low. And house right now is holding between 45 and 54% relative humidity all the time. It goes up a little bit at night when it gets really cold, because we've had these nights where I could drop it in the 40s and 50s. So the system will satisfy, and then the humidity, comes up very quickly when the load's off. So, and I'm learning a lot about latent load actually, and how much latent load's in a house, how long it takes to remove. So these really long run times are really what's needed to remove the latent load, but your coil has to fall below the dew point temperature in order to do it. So what you're going to find most of the time is the lowest you can get your humidity is your coil temp. So, and just in general, that's the way they seem to track each other. So, do you know how many kilowatt hours for 19 hours runtime? So this thing draws, Dave, so that was the question for Dave. It's drawing somewhere between 2 amps and 5 amps on a 3-ton condenser when it's running on low. So I could actually look real quick and tell you for the month. I've got this little Emporia energy meter, EMPORIA, which is tracking the AC usage. So yesterday, my whole usage for May is 254 kilowatt hours for the unit. So,
about $30.
Yeah, and it was about for the week. Let's see here. It was about $8 for this week. So, it is running. I checked this SEER with measureQuick. It's running around 18 SEER, I think, pretty continuously. So, and that's looking at BTUs and watts and EER and turn down on it. So it is making a big improvement overall. So
is that the 37 or the 47 degree coil temperature, Jim?
That's the 47. I haven't monkeyed with it. The whole secret of that BOSS system is the way you control it. It needs 2 stages. So when it goes up to the high stage, it eventually ramps up the inverter. But then when it goes back to low stage, the inverter doesn't respond for about 16 minutes, which drives the coil temperature way down and dehumidifies like crazy during that 16-minute time. And then once it's down there, it runs continuously at a decent coil temperature. And it will, but it's all latent capacity, almost no sensible control at that point. So it's just dehumidifying. Eventually, when it gets warm enough that the sensible heat gets up high enough, it ramps up the inverter again, and that bumps back down. I got a really interesting run trend if you look at it on the Emporia, because you can actually look at it by the minute, by the second, by the hour, and but the long run times are really key for good filtration. And the other thing that with traditional single speed equipment is re-evaporation. So when you if you shut the condensing unit off and you keep the blower running for filtration, you re-evaporate a huge amount of water that's on the coil back into the airstream. And it's sort of like throwing water, on a piece of carpet. It literally takes seconds to get the carpet soaking wet and forever to get it dry back out again. And it's sort of the same thing. So keeping the long run times keep the coil cool, and that's what's going to keep with a cold coil, we keep the water from re-evaporating off of it.
So Jim, are you saying that right-sized variable speed equipment is the answer?
Yes.
Okay.
Yeah, I think so. I'm definitely leaning that direction. And the heat pump, honestly, the only advantage of the heat pump is the low turn down. Electrically, it's not as well, the cost of gas being so low right now, there's just not a payback. But if your overall goal is comfort, I think, and this I will say for 100%, that is a lot more comfortable with the heat pump. So what I did is I just set it so down to 50. It runs the heat pump. Actually, my balance point for my gas furnace at 35,000 BTUs is 45 degrees. So at 45, 50 degrees is when I'm switching over from the heat pump to the gas furnace. So,
yep. We have a paper landing tomorrow actually about basically stopping making air conditioners and only making heat pumps, incentivizing the manufacturer to do that. And we set the changeover at 41 because very few people are going to have an issue there. And it actually showed it's basically cost neutral for the whole country.
Mm-hmm.
$10 and $40 a month. The biggest cost modeled out is $13.
what we're going to find is that, and we can actually control this Bosch unit almost like a single stage unit too, by just changing it to a one stage stat. So I think we should also look at that and how it impacts indoor air quality, specifically temperature and humidity, because one of the things is air conditioning technicians, we don't often, we think about we're heating or cooling technicians, but we forget that, it's HVAC, it's ventilation, it's also filtration, it's also humidification and dehumidification, and even just radiant heating, radiant cooling, just some of the stuff we're doing with our just duct designs and stuff. It all impacts human comfort, and we've sort of sacrificed comfort for efficiency. But now equipment's gotten to the point that it's so good that we can really get some highly efficient systems that also provide us with a lot of, potentially a lot of comfort. But the thing is that is finding the cost-effective solutions that we can sell homeowners that they're going to implement that are going to work, right? I think that's really what what we're hoping to do again at the end of the study. Is really be able to.
We want to learn, I think, A, what works, and B, figure out what actually sells. Because if it doesn't sell, if nobody buys it, it doesn't matter.
There's a lot of stuff we just don't know about. I mean, honestly, I don't know, how well I hear both ends of the spectrum on UV lights and on different. I can't remember what they call it. Photo, where they
PCO, photo catalytic oxidation.
Photo hydroxides or hydraulics, hydroxychloride, or I can't remember what it is.
It's all the HVAC, sure.
Yeah, it's but you wonder about these things. Ozone's another one. I mean, I know some people are allergic to ozone, so it's like we try and create one problem and we create another, and you may drop the dirt out of the air, but then you introduce ozone, which is also a pollutant and a toxin, and you're causing another set of problems. Or in the case of just not controlling, I know for a fact there's been people who bought the Bosch heat pump that haven't controlled it properly. They've had humidity problems. So it's like you try and solve one problem, and you end up with another. And the hard part is with being a service technician is you often don't have time, like the luxury of time we have, to play around with stuff in the lab, because you got to get to the next call and you got to make a living at this. So, again, this is where we're hoping to get some feedback from the group on what you'd like to see us try, so we can try it for you and we can make the mistakes for you and find the opportunities for you, so you don't have to do this yourself. Nate, what Matt Broner is asking, what kind of thermostat we're using? You know what it is. I don't know anything.
I know he asked about your house. You've got that old school one.
I have a Brayburn stat, and I actually put the thermostat down in the basement, and I'm using 2 remote sensors upstairs because when I put the heat pump in, I didn't have enough control wires. So, but the stat we're using for the Bosch system is a what?
Yeah, well, we have a Nexia 824 with IDS, which is an integrated.
Is that the same as IBS? Or is it different?
That's just for you, buddy.
Okay.
But that is the reheat feature, which I'm curious to see how it works. So I've only played with one 824. I mean, obviously Mike Platko of Portman put yours in at your house, so those guys got us that stat. So thank you. There's HVAC power factor 1.0 that yes, it's stupid. It doubles the cost of the stat. Train, come on, guys. You don't need to add $200 or $300 to a stat for the feature. But I'm really curious to see how that works, because that gives you the ability to do reheat with a 2-stage piece of equipment, which is basically what the Bosch ends up serving as. And I'm curious to see at night, Jim, like you mentioned, you get to where you don't have any sensible load anymore, but you have lots of latent. And I'm curious to see how well that stat can do controlling it.
Yeah, I think that there's going to be some interesting opportunity there. So we should be able to figure out a lot of different things as we go on with this. But so anyway, that's the whole goal behind this project. And it's interesting too, by the way, Nate Adams and Michael and myself, we're all Ohio guys. So I don't know how the heck that happened. We're all at different corners of the state. Nate's about an hour from me. Michael's maybe 2.5, 3 hours from us. So then we have our lone Canadian. So yeah, are you guys still building a wall over there to keep us out, or are we allowed? Are we allowed to cross the Canadian border again, Ben?
Oh no, we barely check. As long as you're smiling, we let you pass. So
yeah. So, all right, but anyway, we're bumped, or we've got a few minutes left. Does anybody else have anything you guys want to?
Oh, we want to dive into the design.
Yeah.
So yeah, there's for this type of project, the being able to find the problems and get some data is
Did you
that's
pull up
great.
Michael's
But
designs yet?
we want to do that now. So we're going to
let's
be
pull those up.
yeah.
He's working on screen sharing right now. I can see his concentration.
Not sure if it came up or you can
Yeah, no, it's up.
see.
There we are. Got it. If you can zoom in, it's a wall. There we are.
So this, I think it's important to understand. We're playing around with two different designs. There's actually some books I was reading back from the 30s and 40s that actually talked about some of the interior design for cooling. And I've been seeing this stuff even in airports again now, some stuff where they're actually throwing the air across the room. So Michael's got two designs we're sketching out. We haven't decided which one we're going to do yet. One's more to a traditional design. We're running the duct system across the base and, drop it into lay-in ceiling registers. And this one is a short duct design with 4 supply registers throwing the air across the room. We have about 30 feet, I believe, to throw it across the space. And we're making it sort of modular in nature, so we can do like a standard 1-inch filter, a media air cleaner. We do have outdoor air coming in. Then we also are putting in filter grills, so we can do like a standard filter grill, and then we're sizing it so we can do also undersized return, oversized, sized return properly, undersized and oversized in the supply ducting, just to show some impacts of duct design on control. And then also like we're going to mess around a little bit. I think we're going to put some permanent leaks in the ductwork. In other words, some slide panels or something, so we can bring in hot air from the shop and show like the impact of duct leakage on indoor air quality. Because if we're bringing in outdoor air, we can obviously filter it, but if we have air leakage downstream of the filter or something like that, that's going to create an IAQ issue that we can introduce into the system. So right now we're going to have probably going to try and get motorized dampers on all of the runs, but not control them like for zones, more control them for just changing duct configurations and things like that. So this, Mike, do you want to switch over to the regular design too?
Yeah, I kind of wasn't quite prepared, so it's going to look funny. Because I didn't have everything shut off, but
no, you can get the basic idea. Just get
the basic idea. The returns would stay the same, but the supply would be more of like a commercial setup. Oh goodness.
So, and Michael, you haven't gone through and sized anything yet, right? It's just sort of a conceptual at this point.
Yeah, it's conceptual until we narrow down what we want to do, and then I'll size everything. It's roughly what it'll be, but it will be designed for 2 tons. And what's nice about the Bosch is we'll be able to ramp it up to 3 tons and have an undersized duct system, and then also have extra control on the duct system with the different dampers. So we can kind of see how all that stuff gets affected, and indoor air quality is affected. And I'll be interested to compare HAVEN's airflow measurement to measureQuick's airflow measurement, and maybe things like a true flow grid or something, and see who wins.
Well, don't forget Haven's just measuring like a single point of error, so you'd almost want to like correct for Haven's, because it's, if you've ever done like Chevy Chuff methods of measuring airflow or multi-point with a vane, what you have to do is find the airflow, and then you'll take the Haven and you would just calculate sort of an average, because it's just measuring a velocity in the duct, not really a volumetric calculation. The other thing I was just thinking, Michael, as I was looking at this, even though you screwed up, I think you might have hit on something. We could actually do both duct designs in here, and just damper off whatever duct system we don't want to use. Especially if we did a damper in the main trunk line and just shut off the main trunk, because some of these dampers we can get are almost 100% shut off. So we could look at the two different configurations, and then also look at convective air currents. We could probably get, I think Testo makes they make what's called a comfort probe, which is sort of a hot wire anemometer in a ball, and that they use with the 435. Bill Spohn may have access to one that we could borrow. But we can look at some convective air currents in a room. Believe it or not, in Europe, they have standards for that, and because you don't want to have cold air blowing on people's necks and that kind of stuff. So there's a bunch of different things we could do with that too.
So important point though, like this has been a fun process because this started off as a unit that we could roll around out in the shop and potentially put different pieces of equipment in and then connect it in. So it's been a lot of iteration that has happened back and forth here, or like Jim saying, oh, geez, we need a space we can control. So this went from just being, what the heck, let's just put this thing out in the shop, into this is actually going to be conditioning your space. So this has been a pretty fun process, because it's this is about 2 months in now, Ben, something like that.
Both, 3 months.
Well, and 3, yeah, because it was back in Brian's conference down in Florida that we were beginning to talk about this, because I wanted to use a carrier unit. They're too hard to get. So Bosch it is.
Yeah. Luckily the Bosch rep stepped up and got us a system locally. It's hard to get equipment right, believe it or not. The other thing we're going to do too, I think we're talking about, Ben, is we're going to put a Haven in the outdoor air. We're going to put one in supply air and one in return air, so we can look at particulates. Because the other thing is, you ventilate space, and you're trying to, let's say, with me having allergies, you're trying to ventilate a space, and all of a sudden you open up the ventilation air and it's full of pollen. Hopefully we're going to run it through the filter and that kind of stuff, but we could have a diesel truck outside that's pulling out or whatever that's screwing up the indoor air quality, and we may want to keep that damper closed or close it until we. So there's some control schemes and things we're looking at doing with this too to make it work. Make it work better. Yeah.
You can't do source control if you don't know where the source is. So putting kind of a central air monitor in each one of those ducts, like before the filter, after the filter, in the supply, in the outdoor air too, is something that we experiment with in some of our own homes and test homes, where it gives you a different type of intelligence depending on where you install it in the ductwork. I also love that concept of actually going with both types of duct systems and being able to like almost toggle them on and off depending on which one that we want to demonstrate. We can examine how the flow and the pressure of the entire system kind of changes based on those different duct configurations, and hopefully it's modular enough that over time we can be adding on the humidifiers, dehumidifiers, and other accessories into the system, like throw in an air cleaner and on a weekend when there's nobody in there to see what happens.
That's what the big ass drop is for. And probably, Michael, we should put some canvas collars on some of this stuff. I think you should draw them into design, so we can like off the return duct, we can put a canvas collar and then drop the air cleaner out, put another one in just with a adapter or whatever. So and I know our Bosch rep too is donating a steam humidifier for this project.
Ooh.
So
that's awesome.
So we'll have a steam humidifier on this. That should be interesting also. And the other thing too, interesting enough, is depending on how you make the steam, I have actually seen, like we use at our house, I've got a ultrasonic humidifier that we use just like a tabletop one, but it does the whole house pretty well. But I found if I used softened water in it, it generated white residue everywhere in my house, like a powder white residue. And so, I never thought introducing humidity in my house could introduce more crap into my air. But as soon as there's a cartridge I had to buy for this thing for softened water that basically took the minerals out, or took the salt out. And I think I was getting it was salt. I'm not 100% sure. I'm pretty sure it was salt that was basically getting generated by this humidifier.
Oh yeah,
these are things I never really thought about, and I've been in this a long time, but these are the kind of problems we're trying to, resolve.
Yeah, if you use ultrasonic humidifiers without the right water, it's pretty much just a particle generator. We even have our aerosol scientists has played around with a couple different ultrasonic humidifiers or nebulizers, whatever you call them,
Mm-hmm.
and you're almost able to tweak them. Like if you use the right kind of concoction of water, you can generate almost like a constant stream of known particles that could almost be used for like benchmarking a system. Yeah, if you're generating those types of particles, like if you're not using the proper sort of distilled water in your ultrasonic cleaner, you shouldn't be in that room because you're just generating a crap ton of particles.
And here's the other weird thing is I have a pressure switch on my filter to monitor pressure drop across my filter. So basically I just have it's a little Dwyer pressure switch. It goes into the return duct, and you can set what I do is take the dry setting of the filter, or put a new filter, and I just double the static pressure reading. When it hits double, then I change my filter out. And my filters were perfectly white because this dust is white, and it's loading up my filter. And I pull the filter out, and the filter looks spotless. I'm like, what the heck? Why are these filters bad? They're going bad really fast. But I had white dust in the filters, so it really taught me that, okay, you really got to make measurements, determine if filtering is working and if filters are good or bad, because when you see you can't see white particulates on white filter media. And, so it's little things that you learn along the way. I think are really are very helpful because, like I said, sometimes you look at something, it doesn't look dirty, but it really is. So
the thing that I've consistently found, and I mean the reason that I know is I've been diving into these air quality monitors since 2016, and every time you try and measure something different, you're going to learn stuff that surprises you. So I'm really curious to see what it is. And Ben, I wanted to throw out here, because a lot of people are asking about different products. If someone wants to see something tested, if you're game, buy one and send it to TruTech.
Or to the manufacturer to donate it. We've had a lot of manufacturers step up and donate some product.
Yep, but some of them may not want this data out there. So,
well, I think in all fairness, we're not going to. I've talked to people before. If we have a problem with any product, we're going to contact the manufacturer first and try and get it resolved, because I've found over the years that many of the issues with products are my own issues. I installed it improperly. I didn't control it properly. So I think there's things we're gonna learn as we go. And I think what we're gonna, at the end of the day, what I think more than anything is we're gonna have a list of products we would recommend more than a list of products we wouldn't recommend. I think that's really at the end of the day. I don't want to really bash anybody's product. That's not our intent here. It's just we're trying to come up with solutions that you can implement that will make a difference. So
and understand what works and what doesn't, frankly.
Yeah.
And take some measurements.
Yeah. Exactly. Yeah. Let's measure and find out. So Ben, I love that you pulled up the dashboard here. So I want to give kudos because I have always been paying attention to this. I don't actually like data. I like data visualization. So don't give me a spreadsheet I have to go figure out how to create charts for. Give me nice charts. And Ben and the team, and they're amazing of feedback. And so if you see something you don't like, reach out. Let them know what's going on. And I mean, this is by far the best dashboard on the market right now that I've seen. And I've seen 15 or 20 different instruments at this point. So I got tired of buying them. So I kind of stopped. Especially when this product came out, I'm like, okay, well, this is my Huckleberry for a while.
Yeah, and we want to do a lot more kind of improvements to this where we're kind of integrating additional metrics, like being able to count the amount of times that you've crossed into a certain threshold, being able to even start assigning IAQ scores to your customers' homes that go beyond just the combination of like a particle and VOC measurement. We want to be taking into consideration some of the profile that is gathered during the installation. So like understanding, if there are any IAQ products integrated into the home as a part of the IAQ strategy already, or if the customer is sensitive towards certain types of particles or chemicals, kind of like how Jim is. So like a dynamic IAQ score is something that we're really excited to start adding to the platform here. But like the reporting and being able to provide visualizations of the data is going to be a really important part of this project. And I think somebody in the chat was interested or was asking some questions about Home Assistant. And I'm an avid Home Assistant user. And so ideally what I want to do is to create a dashboard for us that has it's able to pull in information from the thermostat, from the energy monitor, and from the HAVEN device all into a single dashboard. And then everybody would be able to review that dashboard remotely as a part of the project. So that'll be part of the next steps, which is finishing up the design and getting this thing installed.
And I think the other key thing here is that makes HAVEN different is that's in duct monitor versus a tabletop monitor, because tabletop monitors only monitor where they're located. And so if the customer puts it in the wrong location, it's going to be either unreasonably high or unreasonably good air quality, depending on where you put it. And this sort of averages out your house because it's pulling air from, multiple, depending on how your home's ducted, from, I think a much higher volume of air, and then also from multiple locations. In the case of my house, I have returns in every room, except for the bathrooms and the kitchen. So I think it's a little bit different of a product. And you guys been, one of the challenges they've had with particulate meters over the years is you have to have a reference. You have to have like a fan in them or something, so you have a very consistent air velocity. How are you guys? I mean, obviously duct systems have all kinds of variable air velocity. In fact, mine on a variable speed system, it's constantly changing. Is the HAVEN constantly adjusting the ppm count based upon a normalization model on air velocity?
Yeah. So even though that we only have a single point of measurement, we have the equivalent of an embedded anemometer, a pretty high accuracy anemometer built into the platform here that does exactly as you said. It kind of self adjusts to the airflow to make sure that the particle counts that are being seen at that particular airflow are kind of synchronized with that flow speed. And we individually calibrate each one of these devices off the line at different flow speeds to make sure that every single one, regardless of the sort of small manufacturing kind of defects or variability, that they all are reporting kind of within that same accuracy band according to our quality control metrics before we ship them.
I was going to ask you, because I know your installation instructions, you have it before the filter and not after. What's the reason you guys are measuring pre-filter, not post?
Pre-filter allows us to do some calculations on the filter lifetime. So you can technically put it pre-filter, post-filter, like you put it in the duct, it'll produce readings. But if you put it in after the filter, you're able to infer how efficient the filter is, and like if there's any dust or anything that's getting around the sides of the filter, because a lot of filters are just not properly sealed kind of in their slot in the ductwork. So you get a different type of intelligence we recommend before the filter, because then we do those filter lifetime calculations for the customer, and then they get those notifications that let them know that they need to change the filter, not just based on a time-based replacement schedule, but on an actual filter loading based calculation.
But correct me if I'm wrong, but filters get better as they get dirtier, right? So the filter's going to get better and better and better because it's just going to get less and less air through it. So are you guys watching velocity then as part of that metric for filter replacement, or is it just particulates? Velocity will continue to drop off on the filter, right?
Yeah, so we've got a couple of improvements that we're planning to make to kind of update that calculation to include a little bit more advanced metrics and I guess additional inferences about the filter lifetime. We just need a little bit more lab testing before we implement those updates.
So what about like guys in California that everything's filter grills? You know, like, so the filter is the first thing that it sees. Do you guys, is there do you guys, in the app, does it ask you if you're putting a pre or post filter, or have you guys thought about that?
Yeah, we haven't put it as a question in the app yet. We're probably going to be adding that question soon.
Now that you bring it up, Jim, we'll be adding that question.
Yeah, no, we deal with a lot of installs.
It's on the
in
roadmap.
California. Yeah, in the building code in California, I think that it's actually required to start putting in, I think it was like at least MERV 11 2-inch filters. And so like these new filter grills all seem to have that in California. And so like it's perfectly fine to put it in after the filter. You just kind of lose some of the intelligence. But we would recommend, if you can, put it in before the filter. In that sort of, we're actually, and I'd love to kind of make this a part of some of our experimentation. I've been thinking of a couple of prototypes to kind of make an adapter to be able to put it in before the filter in a filter grill. So just some other brainstorming that we can kind of do as time goes on to try to solve some of those problems in those regions that have, like, let's say in, I forget the climate zone number, but in South Florida, a lot of them don't even have return ductwork. You just have the closet where the air handler is. That is the return ductwork. And so we've had some creative techs that have mounted it in such a way so that it's still able to take readings accurately without having that ductwork available on the return side. But yeah, lots of fun stuff to explore kind of as we do experiments in the future.
Yeah, I think there's a couple other questions. Like clean ducts. You have to clean the ductwork before you put a meter in. I would say no, not really. I mean, there's residual dust and dirt that's in ductwork, and if it's sitting there, it's not moving, so it's really not circulating in the airstream. Obviously, you probably do want to clean your ducts periodically, but I don't think you have to clean it before you put the particle meter in. Although you will disrupt it when you drill a hole through the duct to put it in. I know mine spiked for probably 15 minutes after I put the particulate meter in, you know, after initial installation. And I saw too, you guys are sending out the some improved positioning template for the like the sheet metal positioning template to get the rotation correct on the for the installation to get maximum load velocity.
Yeah. So Michael's holding it up right there. That's kind of our solution for both duct board and also for positioning. It kind of gives you a few different spots to be able to hone in on as you're kind of turning this around, because as you know, with airflow and duct work is that it kind of wants to do its own thing. It's never really going to be perfectly laminar for you. And so to make sure that the air is going through the apertures appropriately, we got a bunch of software tools that, like, as you turn it around in the duct, it'll give you that feedback of making sure that you're in the proper airstream. And yeah, we're planning to do some other innovation on this kind of in the near future.
How do you know when the Haven's got to be cleaned?
Well, right now we kind of encourage a cleaning schedule, like once a year sort of thing during regular maintenance. We're working on a software-based tool that's able to identify automatically if it's dirty. And the cleaning process is just like a Q-tip with some isopropyl alcohol just to clean out these apertures here.
And-
But really, the only time you have to clean it is that if there is a really kind of intense particle event, like you're doing some renovations and you're sanding some drywall and making lots of dust.
Fills everything. Yeah.
Exactly. So the drywall dust will stick to it, and then you just give it a quick clean out. But most of the time, we've had some of these devices installed for 2-3 years, and we haven't had we take them out and they're not dirty at all, and they're working perfectly fine.
So what's the what is the oh shoot, I just slipped my mind. Oh, what are the measurements that it currently is taking? Just, I don't think we talked about that too much either.
Yeah. So temperature, relative humidity, PM 2.5, and then total volatile organic compounds. And so really the ones that we're most interested in is those TVOCs, PM, and the humidity, because you're covering the holy trinity of IAQ. So like, if there's particles, you filter it. If there's humidity, too high, too low, you control it. And if there is chemicals, you ventilate. We try to make it as simple as possible. And that's what we want to do with this system too, is to kind of be able to show a very kind of easy progression of like, okay, this is the type of problem that you have. This is the type of solution you go towards, and then choose from your set of, 15 or 20 comparable pieces of hardware to address that problem. And ideally have a lot of conversations along the way about how to address it in a holistic manner where the entire home and the occupant's health is considered when considering the design. Because like for us, we've got the data, and we've got a little bit of we can help out if you call our customer service. We can help out a little bit with providing some advice on what to do, but really it's the HVAC techs and like yourselves, the experts that have been doing this type of HVAC work for decades, that we want to integrate into this system to make lots of videos, tutorials, and just share as much as possible to help anybody, regardless of their climate zone, on how to do better HVAC that can lead to better IAQ.
I think too, it'll be interesting to, there's no free lunch in this. I mean, obviously filters cost horsepower, outdoor ventilation costs, latent load and latent and sensible heat gain, and now subsequent removal. Dehumidification costs running a dehumidifier, right? And there's got to be a balance between, you don't want to overventilate a space. It's stupid. It just costs you money. So, you're having a damper open all the time and just pressurizing a home is sort of silly. You want to ventilate when you need to. You want to dehumidify when you need to. But there's got to be a balance there. It'll be interesting to see, what that balance looks like, because there's cost benefit to everything. And, because this happened in the 60s, we did in the 50s and 60s, we were ventilating the heck out of spaces. And then the energy crunch hit, and they closed all that stuff off, and we got sick building syndrome. And I think now that we're tightening up homes again, and we're relying more on, well, in Canada, you guys actually have ventilation. We don't actually do that in the United States. So, it's something where,
here in BC, all the new homes, it's required by code to have ventilation.
Yeah, our idea of ventilation is put it on the bathroom exhaust fan after a shower. So it is a big problem. So this will be interesting, just to look at the cost benefit. But at the end of the day, you just gotta ask yourself, what's your comfort worth, right? Because at the end of the day, I'm taking allergy tablets right now every day. I'm spending, I don't know, $20 a week, $30 a week for allergy tablets. And if I don't have to take the allergy tablets, have the side effect of that, and can have cleaner air in the office, it's going to be like a win-win. So, those are questions you got to ask your customers too. I mean, I can't go to the store right now and even buy allergy tablets because they're on the, I think I'm going to bake them into meth or something. But also, it's just, you can only buy like 15 per week, and I've got 4 people in my household with allergies, and it's ridiculous. It's a big inconvenience. Wow. There's cost. Again, you think about the cost of controlling the indoor air quality, but what does it cost you for the prescriptions, going to the doctor, for the over-the-counter drugs, for all the other crap that and then productivity. I mean, lost time. Yeah, because if I don't feel good, it's just like I don't feel like working, or whatever. And there's again, cost benefit to everything. So it's all things we got to just sort of think about in a way as we go through this.
Yeah, and hopefully that's because I know that the HVAC 2.0 process has spent a lot of time trying to hone in on that homeowner interaction and how to discuss those types of upgrades of like, yes, sure, there's costs, but the alternatives, like here's a lot of that clarity around the different paths that you could take to solve your problems, and then helping that customer sort of make the decision that's right for them based on their budget, based on their interests, based on their health concerns. So yeah, really, really interested to kind of have Nate and Michael kind of go through that kind of later on in the project. Maybe they can do some role playing with you as the homeowner, and
Not going to happen.
We'll set up a deathbed in the office there, where we'll be interviewing you.
Yeah.
I think he'll be the grumpiest interview that I've had to do. So
I'll be the annoying homeowner that walks around and wants to see everything you're doing and make sure you're doing it right, Nate, because I know how you are.
Well, that's all part of the process anyway. I make your butt sit down at the table and we ask you the blower door. Well, come along. I want you there. Anyway, and do we want to close out by talking about better HVAC?
Yeah, sure. So we're a little bit over the scheduled time, but that's a great kind of segue. So like this whole thing was kind of a part of a bigger picture in that here us as ZOA, we don't think that you can actually solve IAQ without better HVAC. And better HVAC is we're turning it into a hashtag. So hashtag better HVAC is something that we're going to start using on a lot of our content coming up, where the topics might not be specifically about IAQ, but to be able to achieve good IAQ inside of a home, a good 2/3 of that process is making sure that HVAC system is properly working. That is properly designed, properly maintained, and it has the appropriate kind of equipment for the climate zone for that particular home. And we are super excited to work with any technician that's out there, any service company, any manufacturer that's interested in doing better HVAC, because there's just so many big problems that we can't solve with our current approach. And so better data, better conversations, and just better collaboration, I think, is going to be a really important part in being able to really address the big IAQ problem that so many homes here in North America face. So
Waffles is having fun in the background there.
Thanks,
Waffles.
A very important point here. So better HVAC is meant to be a hashtag that all of us can use. Be it better training, be it better monitoring, be it better diagnostic. Whatever it might be. What Jim's doing with measureQuick, what Ben and ZOA are doing, what we're doing with HVAC 2.0. There's all of these organizations out there that are all pulling in the same direction to drag a frankly recalcitrant industry. I've always joked you could take a tech out of 1955 and drop him today, and he'd have to understand a little bit about how circuit boards work or something like that. But I'd say within a week of time, single stage stuff, he'd be fine. We really haven't advanced that much in general. So now we have all this killer stuff out there, but we need to know how to actually use it and to use it better to make our clients' lives better and make our own lives better by making a better living.
There's so much money left on the table because we're just not really doing what our customers need done. And honestly, people will pay for it. If somebody knew you could solve their problems, I mean, honestly, an HVAC technician can probably do more for the health. I can't remember who said this the other day. I think it was Joe Medish. So an HVAC technician can do more for the health of their client than their doctor can, because the systems we work on can have a bigger impact overall. So I think, people understand that you can offer the solutions, and you can, I already know for a fact that you could you could probably double or triple the price or the cost of a lot of these jobs, and people wouldn't even balk at it because it's addressing real issues that they have, and other contractors aren't even talking about it. You know, I think there's so much opportunity there. We just gotta figure out what the best solutions are, so that people can learn from our experience and our mistakes versus making those mistakes on their own. And that's what I think is going to be cool about this project, is at the end of the day, we'll have some pretty good intel on what to do and what not to do, and what products really impacted the overall performance. So,
yeah, I'm super excited.
That's the plan.
Super happy to work with you guys.
Science experiment. But it's not just a science experiment. This is applied science, like you said, Ben. It's how do we take stuff that's actually out there, apply it in something that's pretty darn close to a real world scenario, and see what happens. So this is not science just for science sake. This is science so that we can actually help the industry do better.
and please don't euthanize the test subject after the testing is done. So just please.
It's hard to find new willing victims, so we might keep you around for the next set of tests too.
Yeah, I don't want to be one of those statistics from a or be somebody from the Wuhan lab. So I'm trying to avoid that. So, all right. Well, hey, this is a great event, and thanks for everybody taking a few minutes out of your day to listen to what we're trying to do. And please reach out with any ideas, and we're all open to suggestions in this, and we'll just go from there. So it should be fun. We'll probably get this going in the next, or hope is to get it going in the next couple of days here and really start getting design together. We're going to use some local contractors for the installation, and we have quite a bit of work to do, but it should happen pretty quickly.
So where should we be talking about this stuff, by the way? So, I mean, the HVAC 2.0 Advanced Discussion Group's a great place.
Anywhere you want, as long as you're using the
Ben, what
HVAC,
do you have?
Just need to use the BetterHVAC hashtag is important. Might turn this into more of a community Slack channel too. That's something that if people wanted to add their contributions, they could do that there. But I think if people are interested, they can just start sending emails to pro-support@haveniaq.com, or just follow us on social media, whether it's Instagram or Facebook. And we'll be putting out probably a couple of announcements later on how people can get involved in the conversation. And, does Waffles have anything that it wants to say to kind of end?
No, he just wanted to crawl up my lap. He's been sitting down here. He decided that it was enough rolling around on the carpet. And it was time to crawl up on my lap and go to sleep. So since I can't have a good indoor air quality, I have to have a therapy dog so I can make it through the day. So
Awesome. Thanks everybody for coming.
My own furball who will be, helping to supervise the experiment too.
all right.
All right, bye guys.
All right, get it easy.
Bye, guys. Thanks.
Thank you, Michael.